right, so it's 11 o'clock, so I'm going to go ahead and get started. Today is actually going to be pretty short and sweet. We're just doing 6.1. I was trying to time it out. We're going to cover 3 sections this week, and 6.1 just happens to be a very short section. And I could have probably paired it with one of the others, but then that would have crammed the test review in on Friday, and we wouldn't have been able to get through with it in one day. So I've just kind of spread these 3 sections out. Okay. Wednesday and Friday will be actually take the whole day, but today will be short and sweet. So what we're going to be talking about in 6.1 are radical functions, and actually in particular square root functions. Okay, so square root functions, let's talk about the domain of them first. Okay, now remember, sometimes you have restrictions in your domain, correct? When we had those functions, this isn't a radical one, but this is a if you had a function that looked like this and you were finding the domain of it, remember you would have had a restriction in it because the denominator can't equal 0. So you would have to leave out the x value that would turn this denominator into 0. Okay, radical functions also are going to have limitations or restrictions, or square root functions will, like number 1. You have the function f of x equals the square root of 2x minus 7. So if you were going to graph this, the first thing you're going to have to realize is it can't have any x in the world in its graph, because what is underneath a square root symbol has to be positive, right? If you take the square root of a negative, you're going to get an I in your answer. Remember how some of your quad problems had I's in their answer? That's because underneath the square root ended up negative. And here's the thing with an I, you can't plot that on your graph, right? Where are you going to put it, right? So that's why we're going to have some restrictions here. So what's underneath here has to be positive, or in other words, greater than or equal to 0, right? That's how you're positive. The only way you're negative is if you're less than 0. That's what makes you negative. So I just need to set that up, whatever is underneath the square root, and say that needs to be greater than or equal to 0 to find what this domain is, and then solve it. So I'm going to get rid of the minus 7 with a plus 7. So now I have 2x needs to be greater than or equal to 7, and divide by 2. So x would need to be greater than or equal to 7/2. Any number that is below 7/2 and you tried to plug it in for this x, it would turn what was underneath here into a negative, and you wouldn't be able to plot it. That's why if you were going to go and make your XY chart, 7/2 would be the lowest x that you would be able to put in. Anything below 7/2 would give you, in your calculator, it would give you an error. Okay, so that's how you find the domain. This one is multiple choice, and all the answers have the 7/2 in them. So just make sure that you find the one that has the greater than or equal to symbol, which looks like A in this situation. Okay, so the only thing that's different between the answers is this right here. Now, the rest of these are going to simply be choosing the multiple choice graph of these functions. Okay, so I do want to point out a couple of things. Let's look at number 2. It says graph the function f of x equals 4 times the square root of x. Okay, I'm just going to put that in my y equals. Graph it to see what it looks like. And then come up with some points that I can plot. So going to your y equals on your calculator. And clear it out if there's anything in there. And put in 4 times the square root of x. So hit the 4. And do you see where your square root is? It's on the x squared button, but it's above it. So you would need to hit your second button first, right? Second square root, and then put your x in there. So let's graph it and see what it looks like. That is the shape of a square root graph. All square root graphs have this. They look like that. Okay, this one is steeper. This is what made it be steep, that 4. Okay, so let's get some points. So go to second graph to get your table. Okay, so let's look. I'm going to go up. Look what happens when you go below the x being 0. What did it automatically start telling you your y was? Error, right? Because x can't be this, this right here, x needs to be greater than or equal to 0. So that's why all the numbers, like when you get to -1 and your x, it starts telling you error. You can't plug in -1 here because that gives you an I that you can't physically plot on your graph. Okay, so let's just pick some other ones. Let's see, I'll do 0, 0, 1, 4, and 4, 8. So 0, 0. 1, 4, so to the right 1, up 4. And 4, 8, which is to the right 4, and then up 8. So there's what the graph of 4 square root of x looks like. So this is multiple choice, okay? The thing about the graphs that they give you in these multiple choices is the x-axis, and I don't know, have no idea why they would do this. If you'll look at all the x-axes, they go from -10 to +10, like we always see, like we're used to seeing. The y-axis goes from -5 to 15. So that's why it kind of looks off. So when you're choosing these graphs, just what I would do is look for, it looks like they all start at 0, 0. Oh, no, they don't. Okay, A is obviously out because it's upside down, right? B, C, and D, it's hard to tell. So you're looking at the difference. It's probably not C, right? That's too flat. But B and D, those are pretty similar. What I would do is look for this point on the graph, 4, 8. And it looks like those hash marks go by 2s. So you would look for the point 4, 8 to see which one would cross through that point, which would be this one right here, right? There's 4 and then up to 8. So it does, B does cross through that point. All right, number 3, same thing. This time, the number that's hooked onto the x is going to be a -2. You're going to have -2 square root of x. So just from our transformation section, what do you think that negative hooked onto the square root is going to do to this shape? It's going to flip it upside down, right? That's what those negatives do. It's going to flip it upside down. So again, we just go in and type it in. -2 second square root, oh, what did I just do? Second square root x and then graph it. So you'll see it flipped it upside down. So since this is multiple choice, you can pretty much just look at those, right? There's only one that even has anything that looks like an upside down square root. Okay, if I am going to plot some points, let's see, I just go to my table. Let's see, 0 zeros on there, 1 -2, and 4 -4. Again, starts at 0 0. Then there's a 1 -2, which is to the right 1 and down 2. So that's why it flips upside down, because that's where your next point is. 4 -4. So to the right 4 and down 4. So you'll see that negative just flipped it upside down, which would be A. All right, number 4 is going to look almost exactly like number 2, isn't it? Number 2 was 4 square root of x, and this one's just 5 square root of x. So what that 5 is going to do is it's just going to make that square root shape a little bit steeper than it was in number 2. That's what the 5 is going to do. So in my y equals, clear it, 5 second square root x, and then graph it. So again, it's just a little bit steeper than the 4 square root of x. So I'm going to go to second table, get some points, 0 0, 1 5, 4 10. Oh, 0 0, 1 5. So to the right 1 and up 5, and to the right 4 and up 10. So again, if you are looking at the graph, the only one that is steep like that would be that D graph. All right, look at number 5. If you remember your transformation rules, you would know just by where that +7 is, what's happening to this shape of the square root. All right, that +7 is an inside number, right? That's what an inside number looks like. It's inside your parentheses or inside your square root. It shifts you horizontally, left and right, but you go opposite the sign, right? Which means this +7 is going to shift my square root graph to the left 7. Okay, and you'll see that if you put it in your y equals and graph it. So second square root, put in the x +7, and let's graph it. So once again, you'll see there's your square root shape, and look, it's been shifted 1, 2, 3, 4, 5, 6, 7. To the left, 7 spots. So let's get some points. Second table. negative 7, 0, negative 6, 1, negative 3, 2. So why on this one, how come negative 7 didn't give me an error like the negative numbers we're doing on the other one? The x can be negative 7. The x can be negative in some square root graphs. It's just that that can't be negative. What's underneath the square root can't be negative. So your x is, the x plus 7 needs to be greater than or equal to 0. So if I'm subtracting the 7, x's have to be greater than or equal to negative 7. That means if I went more negative in this x area below negative 7, then I would start getting those error messages. So let's see what that translates to when I'm graphing this. So this first point is at negative 7, 0. So 1, 2, 3, 4, 5, 6, 7. So negative 7, 0. Negative 6, 1. So to the left 6 and up 1. And negative 3, 2. So to the left 1, 2, 3, and then up 2. So that's what it looks like, right? So the graph that you would choose would be the A graph, the square root moved to the left 7, and here's what the domain is telling me. So where do my x's start? This is the very lowest the x's could be, right? What is that number? Where the x is negative 7, right? What happens at negative 7 on the x? The graph doesn't go past that. It doesn't go into more negative on the x. Negative 7 is the smallest it can be, right? Okay, let's look at number 6. F of x equals the square root of 15 plus 3x. I'll put it in my y equals. Hang on. Put this in your y equals. So clear it out. Second, square root 15 plus 3x. There's what that graph looks like. And when you're looking on number 6, look at those graphs. There's only one that even comes close to looking like what's in your calculator, isn't there? Which is that C one, okay? If I do plot, second table, get a couple of points. Negative 5 is the smallest it can be, right? Because going below negative 5, and my x's started giving me errors. Negative 2, 3. I'll just do these. Negative 5, 0. 1, 2, 3, 4, 5, 0. And negative 2, 3. So there's a left 2 and up 3. And when I connect them, that draws it. And last one, number 7. Hold on, short and sweet. Hey. You're fine. Yeah, I'm on my last problem, so it won't be just a minute. Last one, the square root of 7x minus 8. I go to my y equals and put that in, so second square root 7x minus 8, and graph it. Now, if you're comparing these graphs to these, the only two that have the correct shapes are C and D. The thing that distinguishes C from D is look where this one starts. Where does it need to start? It starts on the right side of the origin, right? Look at the difference between C and D here. C starts on the left side of the origin, and D starts on the right side of the origin. So that's why it would be D. These don't, A and B don't even have the right shape. Okay, but again, look at where this one starts compared to where that one starts. So this is the one that matches the graph. Okay, all right. Let me get, I think I got everybody. I got Maggie, Tabitha, Devin, Gabriella, Paul, Clayton.